Somewhere in Germany right now, there's a machine polishing a mirror down to a smoothness so precise that if you scaled that mirror up to the size of the entire country, the tallest bump on its surface would still only be 1/10 of a millimeter high. That single mirror takes close to a year to finish. It sits inside a machine that costs $350 million. And for 25 years, exactly one company on Earth has known how actually to build it. Not two companies. Not three. One. China just built its own version. And when experts at the company that actually makes the real thing were asked about it, their answer wasn't impressive. Their answer was nearly impossible. So which one is it? Because those two things cannot both be true at the same time. And by the end of this video, you're going to know exactly which one actually is, using verified reporting, not speculation, not hype, and not the dismissive one-liners floating around online either. There's a twist buried about halfway through this story that completely changes how you should read everything that comes before it. So if you actually care about who wins the global chip race, stick with me, because skipping ahead means missing the one detail that makes this whole story make sense. Let's get into it. Here's why that mirror matters so much in the first place. The machine it lives inside is called an EUV lithography system, and it's the single most important tool that exists for making the most advanced computer chips on Earth. It works by firing extremely precise ultraviolet light through a series of mirrors to carve circuit patterns onto silicon wafers. Patterns thousands of times thinner than a human hair. Ordinary glass lenses can't even be used here, because this specific wavelength of light gets absorbed by glass almost instantly. The entire system has to run inside a vacuum, using mirrors instead, which is exactly why that mirror isn't just a component. It's arguably the single hardest part of the entire machine to build. Think about the chain this actually creates. Every phone you've ever bought, every AI server training the models you've probably used this year, every advanced weapons system any major military currently fields, all of it traces back at some point through this exact machine. Not a category of machines. Not a handful of similar options from different suppliers. One specific piece of hardware, built around one specific mirror, made by one specific company. That's the actual scale of what's sitting at the center of this story. And it's exactly why a prototype claiming to replicate it, however rough, is worth taking seriously enough to actually understand properly, instead of just reacting to the headline. A standard EUV mirror takes months to produce. The newer, larger mirrors used in the most advanced systems take close to a year, each one finished through a process called ion beam figuring, which removes material from the mirror's surface one atom at a time until the surface is smooth enough to work. Only one company in the world does this at the level modern chip-making actually requires. A German firm called Carl Zeiss, working in an incredibly tight, decades-long partnership with the Dutch company that builds the finished machine, ASML. Building that partnership wasn't quick or cheap either. ASML has poured more than €1.5 billion directly into Zeiss's optics division since 2016, and Zeiss's revenue from that exact business has grown from €1.2 billion to over $4 billion in less than a decade. That's the real scale of what it actually takes to make one of these mirrors reliably, at the level modern chips demand. 2.5 decades of joint development. Billions of euros. A single supplier the entire global chip industry depends on completely. Every major chip maker on the planet, the company that builds the processors in your phone, the company that builds the chips training the world's biggest AI models, all of them, ultimately depend on this one supply chain actually working. Now here's the part that made this specific detail so hard to keep quiet. This entire program was reportedly run as a classified state effort from the very beginning, kept hidden even from most people working elsewhere inside China's own broader semiconductor industry. That's a genuinely unusual level of secrecy for a country that, on almost every other chip-related story, has been fairly open about announcing progress publicly, partly for its own propaganda value. The fact that this specific project stayed locked down for years, while China was simultaneously making noise about other, less advanced lithography wins, tells you something on its own about how seriously this particular piece of technology is being treated at the very top levels of the Chinese government. If a video like this actually helps you understand something this complicated in a way that finally makes sense, that's exactly the kind of breakdown this channel exists to do every single week. And hitting subscribe now means you don't miss the next one, because this exact fight over who controls chip manufacturing is only getting more intense from here, not less. So here's what China actually did. According to multiple independent reports, including Reuters, a covert Chinese research program built a working EUV prototype inside a secure facility, generating the correct 13.5 nanometer wavelength of light using the same laser-produced plasma method that ASML's own machines use. Getting to that point alone took years of dedicated effort. But generating the right wavelength of light is really just the entry ticket. The genuinely hard part of this entire machine has always been what happens to that light after it's created, and that's exactly the part built around the mirror. According to at least one detailed account of the project, the team didn't stop at the light source. They reportedly built their own version of the mirror system too, using domestically manufactured mirrors, and layered artificial intelligence-powered error correction on top of the hardware specifically to compensate for the fact that their mirrors aren't anywhere close to Zeiss's level of precision. Think about what that actually means for a second. Instead of spending 25 years perfecting the physical manufacturing precision the way Zeiss did, this team apparently tried to shortcut that entire process using software to paper over the hardware gap in real time. That's either a genuinely clever engineering workaround or a fragile patch that only works under narrow lab conditions. And right now, there isn't enough independent evidence to say for certain which one it actually is. One account of internal testing describes the prototype hitting roughly a 60% yield rate, meaning 60% of test exposures came out usable. For comparison, real commercial chip manufacturing needs yields above 90% to actually be profitable. So even by that specific claim, this remains a prototype, not a production tool. And here's the twist that changes how you should read literally everything I just told you. The exact detail I mentioned at the start of this video that you'd want to stick around for. The team leading a huge part of this effort isn't a purely homegrown group that spent years building this knowledge from zero inside China. According to reporting from The Diplomat, the breakthrough in generating usable EUV light came from a team at the Shanghai Institute of Optics and Fine Mechanics, led by a scientist named Lin Nan, who previously ran light source technology at ASML itself in the Netherlands. The person who used to help build the real machine is now the person leading China's attempt to build a version of its own. And separately, reporting from TrendForce indicates Huawei specifically tried recruiting engineers directly out of Zeiss's own optics division back in 2024, reportedly offering salaries up to 3 times higher to bring that exact expertise home. This wasn't purely independent invention. This was, at least in significant part, knowledge walking straight out the front door of the companies that built the original. Sit with that for a second, because it changes the entire question this video is actually answering. This was never really a story about whether China can invent EUV lithography completely from scratch, starting from nothing. It's a story about whether the specific, hard-won expertise sitting inside a small number of engineers in the Netherlands and Germany can walk out the door and get rebuilt somewhere else, faster than anyone expected. And that's a genuinely different and genuinely more uncomfortable question for ASML and Zeiss to answer than simply China isn't advanced enough yet. Now let's be precise about what's actually true here and what's being oversold, because both the China cracked it panic and the "this is nothing" dismissal genuinely miss real pieces of this story. Here's what's true. Independent analysis from outlets that have reviewed the leaked details, including Tom's Hardware and TechSpot, describes the resulting machine as a patchwork built partly from scavenged and second-hand components, one that has not produced a single usable chip to date. Some accounts even call it, bluntly, a Frankenstein machine. Zeiss's mirrors require surface precision measured in picometers, a scale of measurement so small it's genuinely difficult to compare to anything in daily life. And independent experts studying this exact case say fully replicating that level of precision would require years of advances in materials science most researchers don't believe China has made yet. To put that precision requirement in perspective, the sensors and actuators inside a real Zeiss projection system are precise enough that a reflected laser beam could theoretically hit a golf ball sitting on the surface of the moon. That's not a loose comparison. That's the actual standard the real machine is held to, and it's the standard China's team is trying to approximate using AI correction software instead of matching it with raw manufacturing precision. China's own laser system reportedly produces somewhere between 100 and 150 watts of usable EUV light. ASML's machines were already hitting 600 watts as their standard benchmark, with a 1,000-watt system announced for 2026. That gap alone means China's version, even if it works, has to expose each wafer for far longer, which makes it too slow to be economically competitive at real production volume. But here's what genuinely justifies taking this seriously anyway, instead of just laughing it off as a poorly built copy. A team built by, and in meaningful part led by, former ASML personnel working from reverse-engineered hardware and an AI-assisted workaround for precision they can't yet match, produce something that generates real EUV light and produces test exposures with a measurable yield rate, whatever that number actually turns out to be once independently verified. That's nothing. Chinese government-linked publications have talked about a production-capable tool arriving around 2030. Western intelligence assessments have generally pointed toward something closer to 2032 to 2035 instead. Both of those estimates assume real, sustained progress from where things stand today, not a finished breakthrough sitting in a lab tomorrow. So where does this actually go from here? Watch whether China's team can genuinely close the gap on mirror precision specifically, because every single expert source on this story points to that exact component, not the laser, not the vacuum chamber, as the real remaining wall. Watch the yield numbers, too, and treat any claim above the officially reported figures with real skepticism until independently confirmed, because self-reported yield claims from a classified program are exactly the kind of number that's easy to inflate and hard to verify from the outside. And watch how ASML and Zeiss respond on the talent side, because if a former head of light source technology and a wave of recruited engineers can meaningfully accelerate a program like this in just a few years, every advanced technology company in this industry now has to treat protecting its own people as seriously as it protects its patents. Expect tighter non-compete enforcement, more aggressive monitoring of who's leaving for competitors, and quite possibly government pressure to restrict exactly this kind of talent movement going forward, the same way export controls already restrict the hardware itself. There's also a bigger question sitting underneath all of this that's worth thinking about regardless of how this specific machine turns out. If knowledge, not just hardware, is the thing that's actually hardest to contain, then export controls built purely around blocking machines and components may only ever be half the strategy. The other half is a fight over people, and that's a much harder fight for any single company or any single country to fully win. Let's bring this together, because individually these are just details, but stacked on top of each other, they tell you exactly where things actually stand. $350 million. What the real machine, mirror included, actually costs. 25 years. How long it took ASML and Zeiss to build that mirror capability together. 1.5 billion euros. What ASML has personally invested into Zeiss's optics division alone since 2016. 60%. The reported yield rate on China's prototype, a number that still needs independent confirmation. 90%. The yield real commercial production actually requires 100 to 150 watts. China's current laser output, 600 to 1,000 watts, where ASML's own systems already stand. 2028. China's own internal target for a working production tool. 2032 to 2035. What Western intelligence assessments generally expect instead. Individually, these are just numbers about lasers and mirrors and a lab in China. Together, they describe a program that used real insider knowledge to compress a problem that took the rest of the world 25 years into a prototype built in a fraction of that time, one that still cannot make a single usable chip today, and might not close the real gap for years yet, if it closes it at all. If this video actually helped you separate the real breakthrough from the exaggerated headline better than anything else you've seen on this topic, that's exactly why this channel exists, and it's exactly why hitting subscribe now genuinely matters, because I'm tracking every single update on this story, the yield claims, the mirror precision, the 2028 target as it develops. And before you go anywhere, I want one word from you in the comments right now, not after you close the tab. Cloned. If you think China genuinely replicated the hardest part of this machine. Bluffed. If you think the mirror problem is exactly what stops this from ever becoming real. Tell me which one, and tell me why, because I am reading every single comment on this video personally. Thanks for watching, and I will see you in the next one.